Today we are going to investigate the relationship between geometry and billiards, specifically when the cue ball banks off the rail. Notice any patterns? The angle at which the cue ball hits the rail is equal to the angle it ricochets off the rail. We are going to call this the principle of reflection.
I'm looking through you. You know who you are.
For our first case, we are going to figure out mathematically where to hit the cue ball off the rail in order for it to hit the 8 ball. In this case, both the cue ball and the 8 ball are equidistant from the rail. By principle of reflection, we also know that these two angles will be the same. We also know that these are both right angles. By angle side, we can determine these two triangles to be congruent. Now, since both sides of the triangles touching the rail are congruent, we must aim for the midpoint of the rail to hit the 8 ball. Let's see if it works. For our second case, we are trying to figure out the same thing we did in the first case, but this time the cue ball and the 8 ball are different distances from the rail. Let's see what we know. First, the principle of reflection, then the right angles, and by the property of triangles, if two sets of angles in two triangles are congruent, the third set must also be congruent. Thus, the two triangles are similar. This means that the triangle on the left is a certain number of times larger than the triangle on the right. To find this proportion, we must find the two distances between the balls and the rail. Let's say 45 and 15. Then we need to find the length of both bases against the rail. Let's say 40. The proportion between the big triangle and the small triangle is 45 over 15, or 3 over 1. This means that there must be 3 parts of the base of the big triangle to every 1 part of the small triangle. It divides up like so. Now that we know these measurements, we have a spot to aim for on the rail so that the cue ball will hit the 8 ball. For our third case, we are trying to find where to hit the cue ball to ricochet off both rails, then hit the 8 ball in the corner pocket. For this example, let's use a diagram. Here we have a diagram of the ball path as it ricochets off both rails and goes towards the corner pocket. Following our pattern from before, we use the principle of reflection, find the right angles, then the other angles are congruent as well. We also know that these two sides are congruent. Given this information, we know the left and middle triangles to be similar, and the middle and right triangles to be congruent. Then, we can break it down into 2 cases, using the method we learned in case 2 for the left and middle triangles, and using the method we learned in case 1 for the middle and right triangles. Or if that's too difficult, you can always do it like my friend Brian does. Well, I hope you see all the geometry that goes into billiards. Until next time.